an interesting point. Well, unless anyone's got any preference, I'll probably maybe run the presentations as scheduled. So I guess we'll start with Raymond Wang with introduction to Snakemake.
Maybe I can.
Okay, yeah, whatever.
And I'm streaming this live on YouTube. If there's anyone that would prefer their image doesn't appear or their voice doesn't appear, please don't speak.
I'm afraid it's too late by now.
Exactly. It's too late for me then. So I'll start.
Yeah.
Okay. So thanks a lot for coming, and hope I don't put any of you to sleep. So it's by chance that my vacation coincided with a technical meeting. I don't think I've come to one for 6 years when I last lived here. So it's been quite a long time. I'm not sure if actually Snakemake is something that any of you have heard of, or at the end of this, whether or not you're interested in, but it's something that I had to learn from my work in the last year or so. So preparing for this, actually, so I'm not an expert on this, but preparing for this kind of helped me solidify my understanding of it, though there's still a lot of things I don't understand. So I'll try my best to answer any questions you may have, but if I'm unable to answer it, then I'm unable to answer it, I'm sorry. So it is called Snakemake, and I'll quickly go through what it is about. So in essence, it's a workflow definition language, so it is very similar to Make. It is based on Python, and it was developed for bioinformatics. So some of you might know that my field now has become, I'm originally a computer scientist, but somehow I'm in the life science. So I'm at the division of life science at the university. I don't know how I belong. Oh wait, I'm being recorded, never mind. So I now do bioinformatics, and that is, in a way, it's basically computer science and statistics merging with the life sciences. So I actually thought when I was learning Snakemake that I think this is general enough that it could be used for many other things. But because of how it started, I think a lot of people are using it for bioinformatics primarily. So I need to admit, well, it's going to be recorded now, but anyway, I'm primarily a Perl script programmer. But I had to learn, learning Snakemake helped me do some of my work more efficiently. And because of that, I also had to learn some Python. So actually, I'm not a very good Python programmer. So I don't claim to be an expert on either one, but I'll cover what I know, and hopefully that will at least make you guys feel whether or not this is worth something to learn yourself afterwards. In bioinformatics, and it seems like more in bioinformatics than any other field that I've been exposed to, like computer science or something, they tend to like pipelines, and that is having multiple programs streaming together as a pipe, but sometimes they output files, so actually you can't put them in a pipe, a Linux pipe, a Unix pipe. So typically you would have some raw data and it goes into one program, you have some intermediate data, you feed to the next one and the next one and the next one. And there's this long chain of programs, and the running time of some of the programs that I've ran could be in the order of hours or days. I've seen weeks. So of course, in that sense, it's good that the programs output intermediate files so that you can continue on where you left off. So I think for longer than some of us are willing to admit, there has been Make, and I'm sure a lot of us have been using Make to build programs, libraries, and source code, either our own or downloaded from somebody else. And as many of you know, the format of a Make file looks essentially like this, where you have a set of rules, and you have some target and some dependencies and some commands that are issued, usually compiling steps to create the target. And I'm sure some of us have had fights with the computer where we argue, no, that was a tab character. No, really, that was. And then you check, oh, right, it's not a tab character. At least I've had those memories of that. And so an actual Make file might look something like this, where you're taking the C file to generate the executable world, and you're issuing this GCZ command to compile it. So in the case of a Make file, you might be using one compiler to compile source files, libraries, linking them, doing it in parallel, and so forth. And I think a lot of you already know about that. So not surprisingly, bioinformaticians, people working in bioinformatics, think that they can do it better or differently than anybody else. And they have actually gone off and done other things that, in a way, it's very similar to what Make would do and other tools that have existed since Make, like CMake and so forth. And they're too numerous to list them all. I don't know all of them. I know one of them, and I will talk very briefly about it, and it's called Galaxy. It actually predates Snakemake, and in some ways, you will see some similarities between the two. The interesting thing about Galaxy is that it is actually a web-based system. So you could go to this website, I think it's off Penn State University, usegalaxy.org, and you will see this interface. So it's based off of their servers. You can upload data and use their computers to do your analysis. And essentially the format of it is you have a set of programs on the left side, and on the right side is data files that you would be uploading and the status of the analysis of various programs. And you can download the code and do a local installation. And a local installation on our servers at the university would look something like this. And again, it looks exactly the same as the one that I showed you on the cloud. So what it looks like essentially is, I know it's kind of blurry, but it's actually not that important in this case. You would have to upload your data to this computer, in our case, our local installation. And this is the size of some of the files, 300 megabytes and so forth, and the status of uploading. So this is at the end of the upload process. And you'll see on the right side, I've covered the window, but you can actually see that there's, these file names are in green, this one is yellow, and this one is grayed out. And that's indicating the progress of the upload. So green has been completed, the yellow is in the process of being uploaded, and so forth. And if you're actually going to do some analysis, you would actually pick a program from the left side, fill in some of these fields, and you can imagine that this program itself is actually a command line program. And what you're actually doing is you're filling in these values that normally you would put as an argument. So this essentially purpose is to simplify things for the biologists. So they don't need to use the command line or know anything about Unix and just do everything through this interface. And yes, the various programs look like this. And as the progress proceeds, you'll see the programs have completed analysis and it turns green. And if you want to do some analysis with another program, for example, this one says to ref gene GTF. That means it's using the input from number 2 here to do this subsequent analysis. Okay, so while it's conceivable to generalize Galaxy for non-bioinformaticians, as it turns out, I actually don't think it's worth the effort, especially those of us who know, all of us who know how to program. We probably do not want to be held back by a web browser. So Snakemake itself, I think this is the first paper that was published by a researcher. I think it was during his PhD in Germany in 2012. And as you can tell from at least the top part of this paper, it mentions that it's in genome analysis categories and bioinformatics and so forth. So I think this is both good and bad. Certainly, I think for bioinformaticians, they will see this and say, this might be useful. But if you're outside of bioinformatics, I don't think you would actually find this or even look for it. And that's kind of unfortunate because I think they did a fairly good job. And if you go to, for example, Stack Overflow, you'll see people are actually posting questions about Snakemake. So I actually think it undersells what it actually does. So the basics, and I'll try my best to explain them. Snakemake workflow is similar, I guess, to Make and Galaxy in a way. So it consists of a Snakemake file, which not surprisingly is called a snake file. And it consists of a set of rules. And the rules have directives, and they are, again, very similar to what we expect of Make. You indicate what are the inputs, what are the outputs, and how to generate the output from the inputs. So a rule looks like this. So if you save this as a snake file, and we call this rule hello world, this is the input, this is the output, and this is the command to make the output from the input. Okay? And here we're indicating the name of the rule, the input file name, the output file name, and here I've indicated that this is a shell command, which I've encased in 3 quotation marks, which I think is a doc string in Python or something. Yeah, okay. I'm not very good at Python. But, and this is, of course, the actual command that you're going to execute. And we note that variables themselves are enclosed in curly braces here. Okay. So if you run it like this, Snakemake hello world iris.text, which would be, I'm asking Snakemake to generate this for me, then it's going to run through and at the very end say 100% done. Okay. So that one's quite easy. Now, clearly, if the input doesn't exist, the command won't work. So if I ran Snakemake with some other file, then it's going to fail, and it says that the input file is missing. So the input directive is a precondition for the rule to run, which is very similar to a makefile. The interesting part about Snakemake, in my opinion, is that it does variable substitution. So for example, I can replace iris with data set in curly braces, and have this being the same. And now I can run either one of these, and it will generate the output file for me. So it will substitute the variable data set with, in this case, Avalon, and in this case, Iris. Okay, so both will work as you'd expect. So like a makefile, there is an all top level rule called all, and it's special in that it has no output defined. So it looks something like this, where you have hello world, and you have, this is the same as before, but now we have an all rule where we filled in data set with the word iris. Okay, and filled in with the word iris, and when you run Snakemake by itself, it's going to substitute it for us, and it's going to run it through. And of course, there are actually two rules now. There's an all rule and a hello world rule. So one will have to complete, and you're 50% done, and the other one will complete, and then you're 100% done.
So will they have any precedence? Which one will be executed first?
No, I don't believe so. But all is special in that it's like the makefile all. So it's going to be looking for that.
Well,
when
the
you
graph would be the precedence.
Yes.
It's building a graph saying these things depend on these other things. So the graph here says that all depends on iris.txt. How does it get iris.txt? It gets it out of the hello world rule. So obviously if iris.txt is not up to date compared to hello world rule's inputs, it must run the hello world rule or hello world command to generate the latest version of that output before it can use that in rule.
Yeah, thank you. But even when you have coded this up, you can still type Snakemake hello world iris. I guess you can put something else in here, and it could end up using this rule instead.
I'm going to question that data set. Is that a particular word you have to use, or you can just stick anything in there and try and figure out?
Anything in curly braces. Yeah.
Okay.
Yeah. Okay. So you can also have multiple input arguments, and here I have two of them, and when I actually run through them, these two will end up doing the same thing. So in this case, this one will put the two file names as inputs in here in order, and this one I've explicitly specified them within the Python list, what they are. Okay. As an alternative to indexing into a list, you can actually name the inputs. So here I've given this, the first one, the name data1, the second one as data2, and I can reference the second one as just input.data2, the name that is given to it. Okay. So within a rule, though, you might need to access some parameters that are non-files. So until now, we're talking about input and outputs as file names. Sometimes you have a parameter that is neither an input or an output file. So then you have a directive called params, and you can actually say, I made this up, obviously, count as being 42, and data set here, I'm saying it's actually that data set. Okay. So without this line, you cannot reference that variable. It's something that took a long time to figure out. So then when you run it, that command, you can actually substitute these values into here, and this would run as you'd expect. Okay. So finally, a little bit more Python. Instead of naming the inputs, you can actually have a Python function to return those inputs to you. And it would look something like this. Here we have the hello world rule again, and the output, the data set again. But this time, the input is going to be a function, which I've called get inputs. And above, I've defined it as a Python function here. And foo is just a name, any name that I could have given, and it will contain the variables that are within the rule. So it'll pass it into the function. Okay, and that means, for example, if I want to get access to this data set, I can do foo.dataset, and this print will work as you'd expect. Also, you can actually declare global variables or something like that, as I've done with outputter here, and this would be substituted in from that. So when it finally returns, you end up getting a list of 2 items, and this would work as what we'd expect. Okay, so that one would be outlaw. So, the more interesting part is, of course, you can actually put the Python code into the actual, the bottom part of the rule. So instead of writing shell, you can actually replace it with something called run. One thing I just wanted to point, I made a mistake here, but anyway. If you have a bash variable in this case, I actually made a mistake. You need curly braces here, 2 sets of curly braces. And this is a mistake that I've made multiple times, and I actually made a mistake when I made this slide. But it's because you need the first set of curly braces to make sure Snakemake doesn't process it as its own variable, and then you need a second pair. And it's something that is the source of many of my own bugs. So we'll skip that one. So in this case, then, this example that I had just counts the number of lines in this file. And this one would do the same thing, except using Python. So instead of shell, I replaced it with this directive called run. And this is what you'd expect with its Python code, obviously. Okay, so you can reference the input file like so, input.input.fn, and pass through and do basically what WC had done. Okay. So some suggestions. Snakemake can be organized better. This is only one of the ways. You can actually do an include statement to include various parts that would be substituted into that file. It could be a mess, but it could also help with organizing. There are cases, if let's say you had a variable for a file input or output file name like dataset-count, when Snakemake looks at a file, let's say dataset has a hyphen in it, then it won't be able to parse whether dataset is iris-2 or just iris or so forth. So one way to avoid this is to declare constraints. So somewhere in the Snakemake file, you can declare a constraint using a Python regular expression and say count can only be a number. So then in that case, count must be 42 and dataset would be iris-2. Okay. So there are only a few things I want to mention. The other one is a configuration file. So you can declare a global configuration file as a YAML file, which would be read in as a global dictionary that can be passed around. And it would look something, let's say you have a config.yaml that looks like this. You put this in your Snakemake file, and then you would be able to access it in something like this. So config is keyword that's been fixed, and datasets is referencing that dataset, and num columns is referencing that. Okay. So some suggestions, I guess, based on some of the problems that I've had. The one suggestion is that each rule should write to a different directory. That prevents the case of a circular dependency, because then you will have nasty stuff happening. The second thing is that if a shell command returns a non-zero value, then that command is assumed to have failed, non-zero error. And in that case, what happens is it deletes the output file, because it assumes the output file is nonsense. And that's actually a reasonable thing to do. It's not a reasonable thing to do if that output file happens to be your log file that has been running for several weeks. So my suggestion is that for the log file, you should not make it as an output. You should explicitly specify it separately so that it doesn't get deleted. Otherwise, you won't be able to debug your program that's been running for days. Okay. So after running Snakemake, there will be a hidden directory called .snakemake. If you want to reset everything because something has been locked or something, you can just erase that. And lastly, if you want to, another way to unlock a run that has been previously interrupted, you can use the unlock parameter. So, yeah. So these are some of the arguments that I've used with Snakemake, which I think are useful. You can specify the configuration file. explicitly on the command line, set the number of cores, show the commands that are being run, output a directed acyclic graph, perform a dry run, list the rules, and force a rule to run and all subsequent rules after it. So of course there are many more commands, but these are the ones that I keep using from time to time. So just to finish up, I wanted to make sure some of what I was saying was correct. So I actually made an example, and I actually put that onto my GitHub if any of you are interested. I guess you just need to remember that part. And all it does is it downloads an example, counts the number of lines, randomizes the ones. I made this up, obviously, and compresses the file and calculates the MD5 sum. If we were to generate the directed acyclic graph using the Snakemake facility, it looks something like this. So this is automatically generated by it. So it passes it to graphviz's dot program. And all of these are in solid lines. If it's in dashed, which I don't show it here, it means it's completed. So you can actually see how far it's gone with it. Okay, so this is actually taken from that Snakemake paper that I mentioned earlier. And this is the second paragraph of that paper. And you can see just within bioinformatics, this is the type of quote unquote competition that Snakemake has. These are all the people, that's Galaxy being one of them, that are doing very similar things. Some of them are using a graphical workflow, a text-based workflow, and so forth. And this is, of course, just only bioinformatics. I think within IT and computer science, they're doing many other things. So there are many to choose from. I don't know why I suddenly fell in love with Snakemake, but maybe it finally helped push me to learn Python. For more information, as I mentioned, I didn't make this, but actually the documentation for it is actually quite good. One thing I felt with the online documentation is that it's actually very detailed, and it took me a lot to convince myself that this was worth looking into. And previously, when I was doing this, I was doing some long workflow that required bash scripting that it took days to maintain. But now after I switched to this, I can add a data set or add a combination or something very easily. So, I mean, on the scale that what I'm doing now, I'm analyzing, for example, in one project, 200 or 300 data sets. So I can add 10 more or 20 more data sets by putting it into the config.yaml and just rerun it. So that has been quite helpful. I don't think I know how to do that in Make, I guess. So yeah, that's about it. So thank you. Give the computer just, should I give the cable to someone else?
Yeah.
Oh, sorry. Are there any questions? Yeah.
How do you do the documentation of your scripts?
Documentation of my scripts.
Do
you
you
can put in. You mean? Well, you can use Python comments in
Right.
line and put them in line. Is that what you mean?
Yeah, I just if there are any special commands where you put like descriptions of the.
I don't know to what extent they will support them. I'm just doing very simple comments using Python, a hash. I don't know if there's anything more detailed like the Python documentation. I don't know about that.
So when you do the inline Python with the run commands, is it possible to import libraries and functions like that so that you can use them within that?
Yeah.
Does it have the ability to distribute tasks across a sea of machines and then wait for results to come back from, or is that outside the scope?
No, it can't do that. And that was one of its emphasis in its paper, which I haven't emphasized because I haven't used it very much. So one of the nice things, so we actually have a cluster of computers, and each laboratory has a limit to number of jobs it can queue at a time. I guess they don't want someone to queue 100 jobs or something like that. So one thing which you can do is, let's say the queue allows only 5 jobs per laboratory. You can actually say Q5, for example, and then it will just wait. And when it actually frees up, it actually throws in another one. So actually that part is quite handy, and I didn't get a chance to mention that. Sorry, what was the abbreviation? DRMMA? sorry, I can't remember. It's Slurm, Son of Grid Engine, those scheduling programs. It supports those.
Okay.
It's very interesting how the list of predecessors to Snakemake is completely segregated from your usual suspects when it comes to general software development.
Yes.
Like there is no mention of CMake or sconce,
No.
nothing like that.
No.
Is it just about documented here syndrome, or is there something specific to bioinformatics that
I
those
mean,
predecessors and Snakemake address?
I think that, so this is in my opinion, and I'm saying this keeping in mind that I'm being recorded. I think that there are some computer scientists like myself that have somehow chosen to dive into bioinformatics, but there are actually a lot of people that are doing bioinformatics, analyzing data that don't have a computing background. They may not know what make is, they don't know what CMake is. And someone might come along and say, well, we developed this program, it's very easy for you to use, you just use a web browser or something like that, and they will happily use that. And I think that has created that niche to grow. And unfortunately, that means that some of the people that made some of these programs are doing it independently of what's already been established for 20 or 30 years. And it's kind of unfortunate, but it allows to give those people papers. So I'm saying that knowing that none of them are my papers.
So you're saying that my papers for ordinary original software can be published if I do them in bioinformatics instead of CS?
Some people actually do that.
Yeah, the funny thing is that when you're using Scholar Google Colab, it gives you a completely different world compared if you just use Google Colab.
Yes.
So once you try to search for some information in the realm of scientific papers specifically, you very quickly fall out of a lot of knowledge that resides on GitHub or in Amazon Web Services. Like they are completely obscured by the kingdom of scientific.
Yes. I think there is a need, I mean, not being my boss, but just seeing the environment, I think there is a need for more computer scientists to get into bioinformatics and somehow fix some of these problems. I mean, not just the tools that I've listed here. I mean, many of them aren't using, well, many of them use Windows, for example, right? I mean, and they don't share their work on GitHub necessarily, or they don't even use Git or Subversion or anything like that. So some of that would actually improve the practices, because in the end, they do have data to analyze and all that. So,
Right.
but yeah, the field kind of exists somewhat separately, and it's only occasionally you have someone from one jumping into the other, saying, "Oh, that what you're doing is strange." Yeah. Okay, thank you.
And next talk, I think, is the VDO transparent line compression and de-duplication by Chris Long. If you need VGA to say, you
Having it up there. I will need it. Okay. So, I'm Christian, and welcome to the presentation about VDO, the transparent de-duplication and compression layer for Linux. So, what's the agenda? Who am I? Some basics of VDO, some use cases, a description on what's the most basic VDO setup is looking like and configuration, and how is VDO influencing read-write performance. And we will also have a look on how much storage can I save for my use cases. I guess I can skip this. Most of you know me. So, VDO. Did ever anybody feel like he has enough storage in his computer? I guess it's the same with his memory or with CPUs. You can never have enough. So, since many years, user-led compression tools are around, like gzip, ARJ, R, and so on. VDO has appeared, the virtual data optimizer. I work at Red Hat, and Red Hat Enterprise Linux 7.5 was our first release to include the code for this. Yeah, this was formerly code from Permabit, acquired in 2007, and freed up, so to say. We are done in including this in our RHEL, but we are still working on combining this with everything we have on top of RHEL, all things like OpenShift and the other software layers. But RHEL is anyway the first step. The code is, of course, open source. This is a requirement for RHEL, but it's not the kernel part. The kernel land is not yet in upstream. It's available on the internet. It's definitely just not yet in the upstream kernel. Not visible here, but see here are actually links embedded. So upstream here is a link where you can directly look at the code. So far, I have not tracked in detail, but I'm not aware of any other distros shipping it. But should not be too hard. Also, PCP, our idea of what performance monitoring will look like in the future after SAR and things like collectcl is also including, since upstream version 4.0, VDO statistics. So you can, when you have a VDO device, see details about the accesses and how much is free and so on. This is the open Bugzilla for getting the version, the PCP version, which includes VDO details, also into the next minor release. This is no guarantee, but here we can track the inclusion, and everyone who's interested can also access and look at the state. So what's it looking like to work with VDO? To the left, we have a normal system, which is basically having a hard disk, having the hard disk available as dev SDA, having a file system on top, here XFS, and having stored two files. I tried with the structure of the files here. This is actually just a copy. So we have two files stored, and they have the same contents. They are occupying 2 times, of course, on this normal file system, also the space. Looking at the same thing with VDO, we have an additional layer here, the VDO layer, which looks bigger than the disk in the backend, which is due to the fact that when you are using VDO, you should actually syn provision, which means the upper layer are seeing more than we have in the backend.
And this is required to take benefit from, being able to compress things to deduplicate data before it gets written to the block device layer. Here we have again the same files, two files with the same content stored, and I try to illustrate here that they're actually then on devSTA is just consuming one time the space. This is actually due to the functionality of deduplication. What's deduplication? Deduplication, I think of it as a special case of compression, which we can handle in a certain efficient way, which is actually just, we have blocks, we have parts of data. We are looking at these parts, we try to identify identical parts. We are removing one of the two and are placing something like a symlink. So we can eventually, if we read, we just have to store the data once, and when we access the data later, we can we are referring when reading this part to this completely written data. Yeah, so compression is also a part of VDO.
The question. So VDO presents just as a straight block device and has no knowledge of what's running above it.
That's true.
That does make it quite different from the look of it than the gzip RAR kind of stuff you're talking about before.
Definitely. We will see what differences.
So that basically means that XFS is not mandatory here.
XFS
It can
is
be
not.
it's not mandatory.
Yes, we will see
for
more. We
VTR.
can place everything on top of it, but it also requires extra thought what to place on top of it. I will say about this a bit later. So what are actually these steps VDO is performing? Here in the first corner we have unmodified data. I try to illustrate that we have zeros in here. And the first step, because it's a cheap thing to do, and also because current data doesn't have many zeros, we are removing the zeros here over to state 2. Of course, we are not only removing, if we were just about removing, we could just throw away everything. We are removing, but we are replacing with references so we can later restore the original state. We have now removed our zeros, and we are going to deduplication. So all red blocks here are meant to have the same contents, which means we actually just need to store one time the red block, and we can, for the other occurrences, just use references. This was deduplication, and you also see referring here to the size. This is a set size, which is currently not configurable. 4 kilobyte blocks is currently the size which VDO is working with.
So you're presenting a standard 512 byte blocks on the device, right? On the upper side of this device.
The upper side we can work with different sizes, but this is what internally.
So, well, to your file system or whatever you're using, you could say you should use half kilobyte blocks, 4 kilobyte blocks, 16 kilobyte blocks, whatever. And the device driver it's talking to will actually say, for example, I'm a block device with 16 kilobyte blocks. If you ask it to do that.
I think our VDO layer to the upper layers can talk with bigger device sizes, with bigger block sizes. But this here is just what we use internally.
Right, but my question is, okay, so for example, can I use a file system that writes only 512 byte blocks on top of this VDO block device?
You can do this, but it will internally occupy 4K, I think.
So I would consider block 0, 1, 2, 3 to be at 0, 2, 512, 124, etc. So I would consider those 4 blocks to be the first 2K in the file system. but you would actually underneath convert them to 4K blocks, taking 16K of RAM during your processing?
I would have to try it out, but I think the smallest unit internally is 4K. We should actually try it out.
Okay.
The last part here is then still compression. Why are we doing this as the last part? Because we are actually here going from the things computation-wise being the cheapest things and being the most likely ones to be hit, to the most unlikely ones and the more expensive ones computation-wise. As for compression, the LZ4 algorithm is used. The reason is that it's a rather fast algorithm and maybe not as nice as good, as providing as good compression rates as the more heavy algorithms. When using VDO, it's also possible to disable de-duplication and/or compression step, if not applicable to your data set. And of course, you might also have data where VDO is not providing any benefit. Then you might then when you notice this with your data, then obviously not using VDO at all is the most efficient thing to do.
So when you're compressing blocks, do you compress each 4K block individually?
Yeah.
Okay.
So we already learned that we are not talking about file system-based, file-based compression like gzip, for example, or something like eCryptFS. We are actually just presenting a normal block device to upper layers, which enables us to do basically everything. So here we have a block device, VDO on top, a file system on top. We could, for example, store self-OSDs on top. Or you could, on top of VDO, use LVM and, for example, LIO, which are the services, for example, for handing out iSCSI targets. Here we have a setup with VDO, LVM, file system, and just normal files. And of course, you can also on top then offer services like NFS, Samba, Cluster, and so on. In the past, we have customers seen there were the ideas of having one big file server, having many clients without disks, sharing an NFS file system to all of the clients, and of course, not every client having its own file system, but having like one big file system. Most of the stuff can just be shared read-only among the clients. So you started then to modify distributions with having subdirectories mounted writable, because you want to write to /tmp, but /user can be read-only, which ended up quite complicated. A nice idea or alternative to this might be to use LIO. So to have one big file, to have an image file on a system with VDO, have this copied for multiple clients, and the clients can freely just hand it this out via iSCSI. The clients are booted via iSCSI. And VDO is looking at all of these images and saying, hey, it's actually all of the binaries are the same. So having de-duplication doing its magic, and then having the required file size shrunk down, the storage size shrunk down. Basically summing up what we had on the last slide here, just also to have it written down. What's installation looking like? RHEL 7.5 has it in the default repositories. There are also channels, repositories called extras and optional, which have different support state because they contain software basically not in our hands. But VDO is just in the plain normal repository, and it also has a normal support status. It's not introduced as test preview or something. It's just plainly supported, like for example Apache or something. Yum install VDO and kmod kVDO will install the required bits. So we have here a user-led part and a kernel-led part. The definite authoritative documentation on this is our storage administration guide, which everybody can access without any subscription or restrictions. So, VDO understands 3 write modes. Mostly these can be, it's fine to not deal with them, but it's a good thing to know about them. The sync mode, I guess the graphic here is illustrating this in the best way. The sync mode is working in a way where our software layer, let's say a file server NFS is writing data, VDO gets the request, it sends off the request to the disk, it waits for the data to be committed to the disk, and then it's replying to the software layer, which was writing the data and saying, yeah, it's written. And in parallel then here, it's also starting to do the de-duplication and the compression if enabled, which is probably the default for VDO setups, but which can be disabled. The async mode, in contrast, here we have, after the software is writing, directly VDO answering with, yeah, it's written, trust me with this. And afterwards, VDO doing its magic and starting to actually write it and doing compression, deduplication, and so on. Basically, the proper mode for you depends on the capabilities of your storage. And actually, you are not required to deal with it, because in most cases, your storage's capabilities are properly read and understood. And on base of this, the auto mode number 3, is doing the proper decision on whether async or sync is being used. For my testing of performance, I did explicitly choose sync and async mode, but without doing this, the auto mode is being used. So what's a simple configuration of VDO looking like? Let's imagine we have a disk dev SDC, which is 10 gigabytes, and let's assume that we want to offer 100 gigabytes to our upper layers. Then we could use a command like this here, VDO create -- name, the name of the device, VDO device we want to create, -- device SDC. VDO logical size is our sync provision size we want to present to our upper layers. And -- write policy is explicitly asking for the async policy to be used. After this, we can directly mkfs, we can mount and use our file system. If it's a file system we want to use on top, we can of course also directly work with the VDO device and do whatever we want. So the block device approach of VDO is giving us many opportunities to not only use file systems on top, but it's also asking us to think on what we are doing. Again, our storage admin guide is quite good in saying what which you should do and what you should not do. Just saying something really, something which you should not do is, for example, having a file system, having a VDO device, having a LUKS encryption layer, and then having a VDO device. The job of the VDO, of the encryption layer is obfuscating the original data. If you store two files, then the encrypted stuff should not look like 2 times the same original stuff, which is taking away the chances for VDO to do its magic. Also, if you imagine you are having a RAID 1 set up, so you have one file system and you want to write 2 disks, people might have the interesting idea of having an empty device, creating two mirror halves, and then do 2 times the VDO layers. This is not the best way to do it. So the storage guide is reminding of these restrictions. For playing, just 2 GB KVM guest is a good thing to start with. The real production requirements depend on the size of your block device. VDO was really designed for enterprise usage with much storage in mind. So we also usually have by default, when we create a new VDO device, 3 or 4 gigabytes reserved just for VDO internal usage, which if you have an overall device of 10 gigabytes for experiments, really much, but if you have typical terabytes, then this is just peanuts. What's VDO doing with this? The typical way of doing de-duplication is looking at the 4K blocks and creating hashes over this, and just storing the hashes in memory. VDO is acting with memory, with storage, which can be so big that we cannot keep all of the hashes in our RAM. So we also are utilizing actually the device itself to store parts of these hashes. Yeah. I should probably say also that this is not, VDO is also not aiming at catching 100% of the matches, So if we stored 2 years ago 1 different block of 4K, which is actually the same as we are just writing right now, then it's likely that this in the past is getting missed. So we are then storing the same block 2 times. Also, we have de-duplication enabled. And this is because this is a trade-off for performance. You want not having your I/O stalling because your algorithm wants to squeeze out the last bit of possible compression or something.
This is relevant both to sync and async, right?
That's true, yeah. You can modify this, of course, also with I will say something about optimization later, but you can also tune the parts, the sizes of how much to be used to cache these hashes. Performance impact. So my idea to look at this was, I store some data in memory. I then make a copy just from memory to my disk, which means either a VDO device or a plain LVM volume. And then already with the on the volume stored data, I make copies. And then I'm looking at the performance. So creating file systems on the VDO device, on the plain LVM volume, mounting, creating a copy. Here, the source is def shm, so my plain memory actually, making a 5 GB directory copy onto the VDO device, and then waiting for the sync. Otherwise, I might just have copied this from one corner of the RAM into a different corner of the RAM without being sure it's synced. And then making a copy of the stuff already on the volume, also on the volume. And this copy of stuff, this is of course a nice use case for de-duplication. Obviously, I know that I have the stuff already on my volume, but again, as userland is CP here, our CP command is writing. Then we have our file system, then we have VDO. VDO is just seeing data. So CP directly knows, yeah, what I'm creating is a copy. Of course, that's my job. But VDO has about this no idea. It's just looking independently about everything coming from the upper layers. It has to look at the blocks again and has to notice, oh, actually, I've written something like this already.
Which means you can actually trick video into duplicating data. Again, if you're for some reason interested in this, by making 2 separate dev mapper entries, both with videos. Like you make 2 devices, so 2 video-enabled devices, and pipe data, even if they refer to the same partition underneath.
They
You
can
can
still
avoid.
on each other if you did that.
So of course, yeah, you take 2 video devices. They will have separate indexes, separate namespaces,
Yes,
so to
yes.
say, for deduplication. Of course. So here I was really just not looking at the storage and compression rates. I was looking at the speed. So let's write the 5 GB from memory onto our plain LVM. Deploying takes 28 seconds, and making a copy is 35 seconds. Deploying on VDO with async mode is 55 seconds, and making a copy is 58 seconds. And doing the same in sync mode, which is playing it safe and before committing to the application, really writing it down to the storage, is initially taking 71 seconds, and the copy is taking 92 seconds. So this was, by the way, the slowest possible backend people will probably use. This was really spinning Rust. And these things, so you see already that writes from the view of the application are not getting faster. But the differences will be different for SSDs or even eNVMe. Also something interesting to notice, if you try...
I have a question.
Yeah.
Why would the impact be lower for an SSD?
Don't ask me, please. I can't say I can't say in this case. Just I was discussing the results here with our specialists, and they said yes. This is what we have seen in all of our tests, in all of what we are looking into, and the differences are getting smaller. The faster.
So it's a matter, the relative difference would change in that, say it takes 30 seconds on an HDD with FXF, and it's about 2 times that when
They
it's a
will,
video.
yeah, the
So it would only be
differences,
like
values
1.5
will be-
times the difference, 15 seconds versus like 22 seconds rather than 15 seconds versus 30 seconds on an SSD. It's not just because everything runs faster on an SSD,
Yeah.
right?
If
Or is it?
because you're storing parts of the hash on the disk, so if for a single block write you have to do a write plus potentially multiple reads, then any
Right, and
difference
you've
is
got
going to
head
be
movement for
multiplied.
the hash in a different area of the disk.
Yeah.
Okay,
Trying to use tar for making copies
Don't
like
use tar
this
for this.
is an interesting thing because tar is amazingly fast with this. It's detecting writing to death now, so it's not even reading. It's just saying, yeah, I'm done. Really fast. That's a nice
But
experience.
how does it know that's the real dev null and not my?
I have no idea how deep it is looking. I was not looking at the source code. I just concluded it has to. So it's looking at the device nodes, or yeah, you could fake this if you do a known kind of driver library. So how can I see how much I can save? And let's also look at the compression rates a bit more. For this, we need VDO stats minus verbose. The output is really verbose, well, as expected. But I'm just referring to a small part here. So physical blocks here is referring to actually 4K blocks, and is the size of our back-end block device. In the example here, 50 gigabytes. Logical blocks is what we are presenting to the upper layers. Here, 100 gigabytes. So 2 times of what we really have in the back end. And then we have the parts here with 1K blocks. We can see how much is internally available to VDO, how much is already in use by VDO, and how much is still available. So this output is directly after creation of the volume, and we see we have already 4 gigabytes in use. This is what we are reserving for VDO itself. And having here 45 gigabytes available doesn't mean necessarily that you can just write 45 gigabytes. If you have nicely deduplicatable data, then this can be, of course, much more.
So this seems to indicate it's using 4K physical blocks on the underlying device, or at least consolidating the underlying device blocks into 4K chunks. But if you do that, how can the compression work? If I take a 4K block from the upper layer and it compresses to 3K, but I store it in a 4K block in the lower layer, leaving the last kilobyte blank, how does the compression save anything?
The 4K base case are actually, well, we also see references here to 1K blocks. So I haven't wondered about this detail.
Oh, I see. So it's just the terminology they're using here. They're actually using underlying 1K blocks.
Yeah. And then you could probably conclude that even if you have excellently compressible data, that you at least will take up 1K of data or something. I haven't looked into this deeper. So using DF, which everybody knows, and using VDO stats, what is it looking like to make a copy of data? Let's look at the first box here. We have df minus h, so everything we see on the file system layer. Our file system layer says that I see a volume, I see a file system with 100 gigabyte size. I have 13 gigabytes in use. I have 88 gigabytes free, and that's it. Just jumping directly to, well, the action I was doing is just creating a copy of these 13 gigabytes. What's DF after this telling us? Well, I have now in use 26 gigabytes. It's not relevant actually for me that I was just duplicating. 26 gigabytes are now used, 75 are free, and that's it on the file system layer. What's VDO stats telling about this? We have a backend here, 50 gigabytes. We were, from the start, after having consumed the 30 gigabytes of data, we have in use 16 gigabytes, and we have 33 internally available. after this copy here, we actually also see with this level of detail, 16.3 gigabytes in use. Just the saving over here is giving us a small hint that actually there was a copy of data we already had. So deduplication was helping us here. So on file system layer, we see 13 gigabytes in use. And here on VDO's layer, this were just 120 megabytes, thanks to the deduplication.
So the factor of 2 between the view of DF and the view of video stats, is it somehow hardwired, or why is it exactly 2? We have, for video stats, it considers the total size to be 50 gigabytes. That's
Which would
basically
be
what
the actual
what
size
it
of
really
the
has on the physical storage. Yes.
16 gigabytes, sir? This is what,
No, the total size, 50.
yeah, this is what our hard disk,
Yes.
the size of our hard disk.
DF thinks that the total size is 100 gigabytes.
It's
Why it's exactly twice as big?
This is your decision as a sysadmin when creating the volume. So let's imagine we have a 50 gigabyte hard disk in the backend, and we would create a 50 gigabyte volume VDO device on top, and we would create a file system on top. We could store 50 gigabytes of data on this.
Right.
Now let's imagine again we have 13 gigabytes stored and we make a copy of this. We would actually not being able to take any benefit of compression or anything because we have not SIM provisioned. Just with starting SIM provisioning, starting to have VDO devices, giving more to the upper layers than to the lower layers, you can take benefit from compression or deduplication. And the factor here is, there are probably best practices, but customers should choose on base of their data. So if you have excellently compressible, deduplicatable data, you might also want to
The source
use a
code.
factor of 4 or something.
Yeah, the source code is excellent for compression, for example. It might give more than 2.
Okay.
The video, like impacts, are
Rather
almost
not.
uncompressed.
Rather not. You might want to not use video.
So what happens? So if you thin provision like that with twice as much space on the top, but then the data that you put in is less compressible than you thought, you run out of space on the device underneath,
Correct.
you get some kind of error, I guess?
Yeah, this is, you should properly monitor the VDO device with this. And this is, of course, an event which you need to handle in the same way as LVM snapshots running over or file systems running over. Yeah.
But it's quite a different thing from a file system running over, because at that point the file system can just say, I'm out of space. But you can't return that because you've already told effectively that the file system using you, yes, I have a block number 17.
Yes.
So when it tries to write block 17
Yes.
which used to have this data in it with new data, and now you have no space to store the new data, what happens? Do you return bad block or?
Currently when this situation happens, you are, let's imagine we are using an XFS file system, and actually in the current state with the current code, we are not even getting the file system data into read only. We are getting the file system data not accessible. And the reason is, if the device fills up and we try to mount this again, then the file system wants to replay the journal. And for this, a bit more file bit more space would be needed, and this is not available currently. So the current file system operations and the way VDO are interacting are leading to not only read-only or something, which would be the default behavior you expect from a plain file system with a plain backend, but with VDO, you even get the data not even readable. To get out of this, you need to increase the VDO device, and then when mounting, the log can be replayed, and you can at least read. And well, if you increased enough, you can also write again. So for this kind of interaction, we have a Bugzilla open to better deal with this in the future. The one workaround I could currently imagine for this is if you have a 50 gigabyte backend, to not use 50 gigabyte from start, but use 49 gigabyte from the start, set up everything, and in case your VDO files, your VDO device is filling up, you have the option to give it this extra 1 gigabyte, which is enough for the top-level file system to replace a journal. So you could also, at least...
So you can add space to an existing VDO device. But what does it actually return to the file system driver when the driver requests, please write block 17, and you have no place to store that data?
I have looked at the output of userland writing to this, but I can't remember the kernel level.
What does the userland say?
I also don't remember, but we have this also reported in one Bugzilla.
Okay, so but essentially what you're relying on here is that someone's using, for this to work reasonably well if it's near full, is somebody's using something like XFS with a journal, and it will fail when trying to write a journal block, and then propagate that failure back and say this thing wasn't written.
Yeah.
Right. So it's something like ext4fs. It might just go, and especially if you didn't sync, it might say, okay, I wrote all these blocks, assuming you can't write them. Tries to write them, and now it can't write them anymore. I'm not sure.
Yeah, you're...
At that point, you have some random number of blocks that cannot be written anymore.
Other file systems might behave differently, and yeah, you're right. You have in the middle layer, in any way, at some point, data where you are the top level cannot be sure whether it has been written or not. So other file systems
actually,
behave differently.
Yeah. But even in the middle layer, so when it's sure it's not written, though, I guess all you can do is say this is a bad block that can't be written anymore, right?
I haven't looked at the what VDO is returning to. Regarding compression numbers, I was creating a 25 gigabyte complete VDO device. You can see here in red our 4.2 gigabyte, which are used from the start, and I stored 60 gigabytes of Gutenberg.org text files, which ended up then as 14.8 gigabytes of stored data. If you take this data.tar file, and so storing did take 608 seconds on a 4-core, 10 gigabyte of RAM, KVM guest. If you compress this with gzip, you get an 8 gigabyte compressed file output, taking 929 seconds on 1 core across gzip. So compression rates are not as good as file-based gzip in our case. But the job is done faster. But for this, of course, we also were using quite nicely the available resources on the system and not just one core as GZIP is doing. Practically, what is it looking like if we copy data on a device and after this make copies? So probably looking at the yellow line is the first and interesting stuff is a plain file system. So we see after creation, we see 0 bytes used and we copy stuff onto the file system. And then we are just making a copy of the data, actually 5 copies of the data already on the file system. And we see it's the whole operation is finishing first from all of the others. And yeah, and you see that more or less constantly our used bytes counter is increasing until the operation is finished. Here we have the internal, the VDO starts from 2 VDO devices. If we see directly from the start, we have bytes in used. We see here how data is copied onto the device. So first the initial copy. And after this, the copy of the data on the device are done. So here is the orange and light blue are actually the DF output. We see more and more being used, and also that the whole operation is taking longer than here for the plain device. But we also see that, well, after the initial copy, here is it's done. After the initial copy, we are no longer using any more substantial internal space. We are just on the DF output, we are seeing further increased bytes now. So takeaways. De-duplication is quite impressive if you have data which is applicable, which can be de-duplicated. De-duplication and compression can also one by one be disabled. I/O is not improving for the applications view, from the applications view on top. VDO was initially designed with really busy systems. For example, having systems with many virtual guests, many processes writing at the same time. Permabit, by the way, was in the past producing black boxes. They were producing appliances for customers, which were taking storage loons from EMC, whatever, taking plain storage loons, implementing VDO layer internally, and then handing out these LUNs to clients. So they were doing like this kind of de-duplication compression on the network as a service, so to say. VDO stats should be used for monitoring the field state. And when benchmarking, loopback devices can modify these results, and using KVM might not be the best thing if looking at performance. And there is a nice video with more details on the internal workings from DEFCON 2018. The main page is nice, and the storage admin guide also has quite nice hints. VDO, so especially when going for SSDs or even faster devices, then you will have to work with the optimization guide. I just played half a day or something with this. So when starting to write, I did see just 4 of my 32 cores on the test system being busy and starting then to tune to have no bottlenecks anymore. And that's it. Any questions?
I just have one more question. When you thin provision a certain amount, can you later change the amount that you're provisioning off the same underlying device?
You want to hand it out to the upper layer?
Yeah.
I'm not sure if it tries this.
And you mentioned being able to disable the compression layer, for example, and keeping deduplication. Is that at the device, the VDO device layer? You create a separate VDO device.
Yeah. So you can have one device with compression enabled and one with having it disabled.
Okay, thanks.
Can you run this on a de-encrypted volume? Like an encrypted volume? Can you run on top?
On top? Yeah. I was just also thinking about the hands-through of the trim commands. So VDO is also dealing with this. But I think also from this aspect, should be okay. I also initially started playing with this, of course, because it came into our software stack, but also, everybody has his own digital life on the hard disk and is wondering, could I get this down somehow? But then you realize actually most of it is JPEGs and movies and just the kind of uncompressible stuff where eventually, for this kind of thing that doesn't make sense.
Uncompressible, but still maybe to an extent deduplicatable.
Indeed, yeah. For the deduplication stuff, true. But if you have really many files, which are, then you have of course, there's also fdupes or nice userland code which can detect this and can then work with symlinks and hard links and something.
Yeah, I was thinking this would have been very useful a couple of decades ago when users first figured out how to send Word files and so on to thousands of people on a corporate mailing list.
It still happens.
Yeah, I was also just remembering the way Google is storing emails not into the 20 inboxes where actually on your you might want to receive the email, but just storing it in one place and then flagging it so you see it in multiple places or something. Yeah, it's doing deduplication on software layer versus Then, thanks a lot. Should I do the next one or?
Yeah, I mean, or do you want to?
No.
Well, yeah, I will do it in the order.
Just to save on overheads.
Yeah.
Context switching takes time.
Yep. Okay.
Okay. Then I have not prepared slides. I will actually just go through my website regarding the topic. But let's maybe start with some pictures. This is about Nintendo Switch on running Linux on the Nintendo Switch. Maybe let's start here. So why does one want to do this? Because it works. Because so my colleague asked why I got the Nintendo Switch, and you have been playing a lot with it. Yeah, really. But Super Mario was just 2 hours and like weeks with Linux, of course. So the kind of playing is just different. What do you need? You need currently 2 things. Obviously, the Nintendo Switch. So there are game consoles like past PlayStation modules, which were initially meant which had in firmware the option to run third-party like Linux. The Nintendo Switch is not meant to this from Nintendo itself. So there were really great folks, like here, Fail Overflow Group, figuring out how to get the device into a mode where you could run own stuff. For this, you need also to do a bit of hardware. I was also asking on the TLUG list, and eventually at the Tokyo Hackerspace, at one of the Tokyo Hackerspace producing this year. So shortening two pins, which are usually used to connect one of the two Joy-Cons, is one of the requirements. And then you can turn on the device and can then jump out of the typical secure boot style chain where everything is really verified which is booted, and you can instead provide home code. Further inconvenience as of today, you cannot right from the start just with this device boot anything on the SD card. And so we have two storage medias. One is like the faster. The faster is D-card, which is proprietary and from Nintendo, and we have a plain SD card over here, which has multiple partitions, which I also use to install multiple Linux distributions. So after using this device, after turning on the switch, you also have to connect via USB and have then to hand over code you want the system to run. So most people playing with Linux on top think of running emulator of other systems of Super NES, of Famicom, and so, which is actually accomplished. Just still to get Linux running, you still have to connect. People are also running the first step via USB with their Android phones. This works. Yeah. So eventually you can run Linux from CSD card. I have multiple partitions here, and working at Red Hat, my first priority was getting Fedora to run, and then Debian is running nicely and SUSE is running nicely. One big drawback is still kernel patches that come from fail overflow and are available publicly, but not upstream. And two things everybody would like to want are not yet there, which are the controller, being able to use the controllers, and having sound. 3D acceleration is nice. Something I was also interested in is getting the chip actually to run some kind of machine learning, but I think now I was at the OS Summit in Tokyo talking with a guy, and I think the chip is not prepared for running any of the AI code accelerated. So what's here? So I did just play a bit on userland. I did really just figure out how to best install Fedora on it, how to recompile some X packages so I get accelerated X. This is actually working nice, but really big thanks to fail overflow. It might also be that the other parts are now stagnating and maybe not even advancing. So some people from the groups, two groups at least, have discovered the issue, which did lead to Linux being booted. And unfortunately, when such things are discovered, and they did this, of course, for the hack value, to run something the device was not intended for. But there is already one company coming up which is commercially trying to offer an own printed device here, and also something they plug in. They also have to rely on the USB. They are plugging in something like a cartridge, where this cartridge is then providing the Linux kernel and everything to be booted. So people trying to commercialize this to run pirated games and stuff on top are so fast that also fail overflow. Some people have stepped back and said, oh yeah, now it's getting less interesting for us. And I can understand this. So some links. Yeah, reswitch is nice. The Linux kernel, initially getting Linux to run starts with getting a cross compiler for ARM installed on Linux and cross compiling a Linux kernel. What's working, what's not working? Actually, so Arch Linux is the image everybody is basically using. With Fedora, thanks to recompiling some packages, I got basically the same functionality level to the things I'm interested in. So graphical demos are running accelerated, and you can run Doom, for example. One of the two Doom ports I was looking into, the most modern Doom port did with unresearched error messages not work. Maybe. Architecture-wise, this is ARM Architecture 64, and this was also one of the reasons I tried. I wanted to look into this, finally something not x86. Debian is also nice. On the Fedora 28, you just say dnf install d bootstrap, and then you can just bootstrap the whole file system. Quite nice. SUSE Tumbleweed also very nice. There is an issue with overheating. Running big compile jobs for a long time by default over the forkers is causing issues. So restricting this down to 2 is working. And of course, Nintendo is rumored to work on new hardware releases. Now it seems like there is, this is just from yesterday, that there is hardware being sold, which, as it is sold with an older firmware, can still run Linux, but once updated to a newer firmware, this seems to be lost. So a bit about the hardware. 4 big cores, 4 smaller cores, NVIDIA Maxwell GPU, and 4 gigabytes of RAM. The wireless network is also, wireless is working. Interestingly, due to probably some driver issue, just after run reboot. So we also learned we have no input yet. So you start to compile a Linux kernel, you write it onto the SD card. You run this with a distro. You get into a prompt, and you cannot do anything to interact with your installation. Debugging is really nice stuff. So you start with modifying etcrc.local to just dump output to your console, and having the first time established Wi-Fi connectivity is then your step to log onto the system and do real debugging. Some details on the first steps, just getting something to run. How to install Fedora, it's not like inserting a CD. Obviously, you are actually just on some x86 system, just creating a file system, extracting the image you have on the internet, writing it there, doing some preparations, and then putting it on the Nintendo Switch. There was this thing with network also, with wireless also working just after reboot. How do you initiate a reboot if you have no way to interact? So you create just a loop which is detecting is it the first or the second boot, and then you are writing a flag file, doing a reboot, and after the second reboot you actually stay there, and then you try to connect to the wireless network. Yeah. Wireless. Yeah, for Fedora Xorg 3D acceleration, I was recompiling two components, libdrm and Misa, yeah, which took time to figure out and takes time to compile, of course. Some graphical stuff, yeah, some graphical demos for trying out. Once X is running, you can also, of course, use screen. You can log on via SSH, and you can use something like Synergy to use the keyboard of a different system to remotely control the Nintendo Switch. Debian runs nicely, and when I say runs, then this always is relating to the user land actually, because everybody is running still the 4.16 pre-version patched from the guys originally finding the issue. This is not the default. These are not the default kernels from the distros. Yeah, Debian is also nice. Yeah, I did not get DRI and Visa on Debian to accelerate its state actually. So this is tumble read. Yeah, it's a bit slow. Yeah, and that's about it, I guess. Any questions?
So what games did you have?
Just Doom. Yeah, I was just looking into Doom. Oh, and Tux Racer. Oh, and this also brings me to this is just side pictures or something. This is the 3D printer at the hackerspace. Something behind Ikebukuro. And yeah, really nice guys. And yeah, first time booting and not finding the root file system, and yeah, and having X running for the first time, but without accelerated X. Actually, Firefox is segfaulting, and here you see my katakana still not being printed properly. Yeah, this was from running Debian, being logged in remotely via SSH, and there is a great graphical demo called BB, really great, using AALib, and TuxRacer was the other one. So I was actually using Synergy, controlling this system, and then playing like this, right, in experience. Yeah, and GL Mark, I think, yeah, this cat is turning around. Things like this. Someone on the internet was asking, can I run Twitch on this? And of course not plainly, but as Flatpak. And I learned, yeah, Flatpak is as easy as DNF install Flatpak. And then also the Twitch application is basically some GNOME proper about opening browser style stuff and then presenting you this screen. Twitch is this platform where people are watching each other playing games. Yeah. Well, works. Okay. Questions? Then the next one.
The next talk's introduction to Matrix, a platform to unify decentralized secure communication.
Well, display port is also as well. Yeah. Let's thank you. Hello, everybody. I'm Alexey Rusakov, and I'm going to talk about a platform for unified, secure, decentralized, real-time communication called Matrix. This is a project that is running off Great Britain and France mainly for the last 3 years already. We're pretty far by now, so I guess it's well over the time to introduce the whole thing to Japan finally. So to start with, can you throw in as many instant messaging or otherwise real-time communication networks you can remember?
Just say them?
Yeah, just throw them.
Oh, yeah.
I will just count. ICQ, yeah, also.
ICQ, AIM.
AIM, yeah.
Yeah.
Slack,
Right.
more. Telegram,
Signal.
Signal.
Wire.
Wire,
Yeah.
Line.
Mastodon,
Mastodon, okay, Mastodon, yeah, okay, I count that.
Rocket Chat.
Rocket Chat, Mattermost.
Big chat.
I already counted 10.
Riot. Well.
Well, that's coming.
Next cloud talk.
Hmm?
Next cloud talk.
Yeah.
Yeah.
So more than 10 already,
Oh.
or a dozen. Just right off the top of our heads right now. I guess there are like twice as many. In fact, we haven't mentioned Viber, that is owned by Rakuten at the moment. We haven't mentioned all those proprietary kinds like Facebook, Messenger, and things like that. So there is a vast diversity of networks like that. And how many applications on your mobile phones are installed to cover your communications? 2, 3, 4, 5? I guess certainly more than 1 or 2. So that's basically this setting, what we are trying to address with Matrix. This is an open network for secure, decentralized, real-time communication. In a nutshell, this is about interoperable chat, interoperable voice over IP, as a kind of a leap of imagination at the moment. This is open communications for virtual and augmented reality, and another leap of imaginations for real-time IoT data exchange. This is what we have right now. This is what we want to get to. We partially already got, actually, all these are already covered by Matrix. The next thing I asked on my first meetup about Matrix was that one. XKCD has mentioned the thing that, yeah, okay, you are going to introduce yet another instant messaging protocol. So instead of 14 standards for instant messaging, you were going to have 15 standards, aren't we? Well, yes and no. And my presentations will try to cover why basically no. But first I will talk a little bit about features of the Matrix as the communication network. This is something based off at the moment, HTTP, REST over HTTP, if you will. Interaction between servers and clients. This is not a serverless architecture, just so that you have some basic ground. So now, no single party owns the conversations. It's distributed. Conversations are shared to an extent across the participants, to that extent how much you actually request them to be shared, and the rights you have for those communications. It can be used for group chat, for WebRTC signaling, WebRTC is notoriously signal-less protocol, so you have to do some external signaling for that. Communications in VR, AR, breaching those silos that we've just mentioned. Internet of Things data, and anything else actually which needs a publish-subscribe framework over HTTP or something maybe more application-specific. Because the protocol itself is actually generic enough to exchange any kind of data, pretty much generic one, because anything in the end is exchanged in the form of events, packed up into containers called rooms, and clients are supposed to subscribe to events coming from servers to them. And then servers are exchanging information across the federated network. Here, I actually told everything. I can finish it. It's as simple as that from the user perspective. So it's like a permissionless blockchain, or it's like, think of it as Git for real-time communications. The rooms are decentralized. You don't have that kind of thing as in, for example, IRC, when you have a particular channel and this channel is confined to a specific server. You actually have a room that is federated across any servers, participants from which servers are in this room. There is no double spend protection, which means we don't do any kind of de-duplication, or like we don't actually distribute all the data and then have the clients connect to a specific endpoint simply to request the data, because you have to know where the data resides. You have a single point of contact from your client. This is your server. You can request from the server whatever is available in the network.
Stupid question.
Yeah,
What
yeah.
does POW/POS stand for?
Proof of work.
Proof of work.
Okay.
Yeah, this is from the from blockchain. Proof of work and proof of stake. This is two basically ways to confirm that you don't. Basically, it's a way to add a new entry to the blockchain, to the distributed graph, so that
Everybody agrees when I come up with a new block and you come up with a new block, both with the same parent, which one is the real new block.
yes, thanks. Okay. Exactly.
So is this a chain, like a single chain, or is this a graph?
It's a graph. It's
Okay.
it's a classic duck, actually.
Okay.
It's a usual Merkley duck.
That's why you said Git.
Right.
Then yeah, you can layer transactions on top of that if you need. You still there is still a kind of power levels system to make sure there are ways to administer the rooms, issue kicks, bans, prevent people from sending messages at all if you want some kind of a broadcast, for example. Consistency is gradual and eventual, which means that if two servers have to send events across each other, you may easily have them getting out of sync with each other. So two persons sending events to each of their servers cannot guarantee that their events will be ordered in a particular way when the third party tries to retrieve the information to their timeline of events. So the timeline can easily look different on two different clients simply by the fact that those clients are connected to different places in the network. The consistency is eventual.
Nice.
I think we've got some way of merging,
Sorry?
having merge blocks with multiple parents that can bring it back into.
Yes, we do have that. Basically, the servers are responsible for doing that.
Okay.
The thing called state resolution. So it also refers to for things like joins and parts, for example.
Mhm.
So you have to somehow resolve the situation when a person is joining and then somebody kicks him and like immediately, and then he joins once again. And you have to make sure that that second join is after the kick, because if they are ordered in a different way, then the person is screwed.
Yeah, and just to be clear, each room here is a separate DAG for that particular.
Correct.
setting.
Correct.
Yeah.
So this is the architecture that I already mentioned, with addition of two more things. So you have a federated network of home servers. Clients connect to a particular server, but actually, as I will show later on, you can have a single client connecting to two servers at the same time. You just will have to use different accounts. So it's as if you have two identities in the network. Then, in addition to that, we have identity servers that basically store the information about how you want to be represented on the network. So instead of using the native matrix ID, you can be identified by an email or a phone number or your Twitter handle. And the identity server confines the information, who is who. So you can do some kind of opaque handle in matrix network, and nobody will know that this opaque handle actually is connected to that particular person in real life.
What identifies each of these clients?
Each of these the client is an application.
Right, but how do you distinguish two different clients?
Well, every client has an ID that is assigned to the server to it, if that's the question.
Oh, I see. So the servers are actually determining who's whom, or like, so the clients don't have, say, a key pair where you can say anything signed, anything where you can prove it was signed by this private key is obviously this client.
Yeah, so the thing is, first off, you need not to, like, this is not mandatory to have things signed or encrypted. So
Right.
you have, the DAG only exists on the server side.
Okay.
The DAG is not, as a DAG, it's not exposed to clients. So clients cannot mess with the graph for that reason. They send an event to the server, and then it's the responsibility of the server to incorporate the event into the graph. Still, there is a case when you are sending an event in an encrypted fashion, like because Matrix provides end-to-end encryption. Then you actually have to make sure that you are yourself. This is made by the usual public-private pair of keys. You are sending the message signed by a private key, and then the server does not know anything except the metadata that are necessary to bind this event.
Right. So the server just puts it on the chain. It goes out to everybody.
Right. The server does not know about the contents of your message. It only has the metadata necessary to bind it into the graph. Then it can share this message, still encrypted, with other clients, and then those clients using your public key can verify that this message is actually from you.
So this implies that you don't support perfect forward secrecy.
Correct, it does. So the other thing that is here is the application server. The thing with the application server is that you might want to interact with a different network. That's what Matrix has been made for, partially. In order to accomplish that, you have a so-called a bridge that is a client, or in other way is interacting both with Matrix and that other network. For IRC, for example, that would be another IRC bot. For Slack, it's I guess also implemented as a bot. There is a client for Mastodon, etc., etc. So application servers are responsible to connect Matrix to all the other networks that we can connect to. This is the ecosystem as it exists right now. We have the matrix specification as the kind of a point of truth with regards to how clients and servers interact with each other, how servers interact between each other, the federation spec, how application servers work with home servers. The servers are the most complex, the most difficult part to implement in this setup. This has been intentionally done so that we could relieve all the whole world from the complexity of organizing a distributed acyclic graph, from federating issues, etc., etc. This is basically done by the first generation matrix server Synapse that has been made originally as a proof of concept with Python twisted, but people could not contain it, and the thing just like went everywhere. People started rolling out their own Synapse installations, and now we actually have plenty of places where Synapse is getting used. And we also have the matrix.org Synapse server still running in production, completely overwhelmed by the traffic because it's Python twisted. It's hard. The second generation Dendrite is getting rewritten in Go language so that it could actually sustain all the load from the network. It's still not ready, it's still in the works. We have some pretty good progress by now, and finally, I hope we will get something working by the end of the year. And then we will at least have some good throughput through specific contention points as, for example, matrix.org server is now. Then matrix application services and bridges are interacting with those servers through the well-defined by now protocol. And other servers and servers can, in theory, connect directly to servers using the application services spec. On the other side of the fence, there are numerous clients. The reference client made by the matrix.org founders is called Riot, and this client is mainly using the web-based technologies. The original version has been made as the browser web application, then an iOS application and Android application has been made, but they also use that nice React thing in order to work. Then there are plenty of other clients by now. We have clients implemented in Qt for KDE, in GTK for GNOME. We have other web-based clients. We have the console client. I will give a brief overview of what we have at the moment later on.
Sorry, did you just say Riot? Are you talking about riot.im?
Yes.
Oh, okay, so that's actually fine.
Yes. Actually, riot.im is exactly the web client for Matrix. It uses Matrix. So what do you get in the API specifications? Decentralized conversation history, group and one-on-one messaging, but in fact, one-on-one is still just a particular case of a room. Voice IP signaling for WebRTC. Entrant encryption, currently in the very late beta. We are still ironing out some wrinkles, but it's pretty much good. Server-side push notification rules, server-side search, read receipts, citing notifications, presence, all the things that you typically expect from an instant messaging network. Synchronized read state and unread counts, decentralized content repository, and account data for users per room, and some limited amount of account data per server. So how does it work? Actually, I already described mostly how exactly it works. And I'll try to open the About page at the moment. So this is what happens. Basically, you have three servers here, Matrix Alice.com, Bob.com, and Charlie.com. Clients are connected each to each own server. When the message from one client is sent to the server, it's attached to the distributed acyclic graph and federated to two other servers when and as they request it. And the servers do exactly the same. Then once you have it, clients get this message through the sync protocol, through the synchronization protocol. Now Bob responds to this message, and this message also gets attached to the graph. Charlie responds to the same message. Now you have the diversion. On the Charlie.com has both messages attached to the same message. And it federates. And you have basically the same on two other servers. Now what happens then is Alice is responding to either of the messages that it received. We actually have no way of knowing to which message it responds. The message 4 just gets sent, and it gets attached to both 2 and 3. And it gets federated. And it gets delivered to the clients. This is pretty much it. In a nutshell, this is what is going on. This is how the client-server interaction looks like. You simply make a REST datagram. We use JSON here to a particular endpoint on the Matrix server that contains the body that describes your own message, and the server responds to you with an event ID so that you could identify the event on your end. This is how establishing a WebRTC call would look like. Again, it's just a post in the REST protocol. Voice IP matrix signaling is looking pretty much minimal, but exactly like you would expect the signaling protocol to look like. First, the caller sends an invite event, then the candidate events. The callee responds to an event with an mcall answer event. Then WebRTC interaction kicks in, and you actually have a call. Upon the end of the call, you have the event mcall hangup. All of those events are also attached to the distributed acyclic graph, so you don't have, of course, the WebRTC part in the graph. You still have the metadata that people established the call, then they hang up. On the other hand, you can throw all the real-time messaging out and just use the thing to persist some information. For example, like that, you have invented your own event type, like org matrix MIDI type, and you send the MIDI file, save it into your distributed acyclic graph, and have a version control system saved on your server in that way. The server-server API, as I said, it's much more complex, so there are much more letters on the slide. What servers are basically doing, they are exchanging two types of entities, the persistent and the ephemeral. The persistent entities are getting to the DAC. The ephemeral are only used to provide some status information to other servers across the network, but they are not actually attached to the graph. For example, tracking notifications have no much value getting attached to the graph. They are just broadcasted across the network, and that's pretty much it. What happens to them? Clients receive them, but if clients try to receive some historical type of notifications, there is no such thing. The application service API. Basically, this API provides a way to extend the functionality of your server. There is extensible custom application logic, the privileged access to all the inouts of the server, including the distributed acyclic graph. So even though application server is just a client on steroids, it also has the extended privileges to get the information from the server. And exactly for that reason, you have to specifically register the application service on the server so that it gets those privileges. The server has to know that what gets connected to it is actually supposed to get extended access. Question?
So any server offers this API?
Sorry?
Any server offers this API in the same way they offer client API?
Basically, yes. The servers are supposed to provide this API. This is a part of the specification.
And how do you decide which servers can talk to each other?
There is a way to limit the federation between the servers. So basically, the server can define that I don't want to hear anything from that guy. So if a malicious server gets connected to the network, you can ban that server from your server to protect you. This is actually a very recent addition.
Right, but what if it's not attached directly to you? It's attached to somewhere else in the network.
Eventually, you have to somehow establish a wall, because this is This is a problem that we experienced just this spring, when actually we've got our own bad guys coming in finally, and what the guy tried to do is he tried to abuse the known vulnerabilities in the state reset algorithm that conflict resolution when several events coming in from different servers to subvert the graph, to elevate the privileges, to replace the room contents, etc., etc. So what we had to do is basically we had to introduce a way to outright ban the server from messing with the distributed cyclic graph, so that we cannot implement the banning coming through the federation protocol, because again, this server can easily work this around, just ignore the ban and do its own stuff. And in the end, it of course comes to a net split. You just cannot avoid that. This is a hard world. You just have to be either on that side or on this side in this case. But this is not a net split that occurs like right now, right here. It's rather something that eventually becomes apparent. So if some server bans another server, then it basically starts a wall that further has to be
So for
drawn
connections
across the
between
federation.
servers, is this done on a connection by connection basis, or do servers have some sort of identification? Like there's a list of public keys and only servers that can sign
The federation is entirely signed. Like you cannot just send an arbitrary thing through federation.
Okay,
You
so
have to
basically I
sign,
can connect to
you have to
anybody
sign
I
it with your
want.
keys, with your server
But
key.
so all messages in here are signed with some server's key?
Through
or-
federation, yes.
Okay,
When a particular federation interaction occurs, things are signed by the server's key who sends them.
right, and then it's up to any individual servers to which they're connected to
Right.
decide, I will accept this as a new node on the graph.
Right,
They're not based
right.
on the list of keys I
Exactly.
believe are the ones allowed to.
Exactly.
Okay.
Exactly.
And how do you update that list of keys? Within the graph again, or?
Well, yeah, basically servers get like the usual negotiation protocols, and they send keys to each other. We can have key signing parties, of course, but that's just, we understand that over a scaled, it cannot be done in a scaled manner.
Right, but for example, say I've got 1,000 servers in my list of authorized servers in this federation, and I want to add a new one.
Yeah.
What do? I create a new message signed with my key for server A saying
so
that
you have to start with why you actually want to participate in the federation in the first place.
Well, say I started the federation, and someone else.
I started the federation to for what?
For my chat channel.
In order, so you want to somehow make the room that you have started on your own server be available to other servers. Is that correct?
Correct, and not just available to other servers, but to allow them to put messages into that room.
Right. So what has to be done in this case is that you actually establish the connection to other servers.
I have to be directly connected.
You're connecting to some of them.
Okay.
Then you exchange keys so that you can identify yourself and they can identify themselves.
Okay.
Once that is done, you are basically in the network. You can interact by either pushing information.
I actually want to go into a little more
pulling.
detail, so maybe we should just do this later over.
Yeah, I guess
we've got
so.
time to walk through the exact
Yeah.
steps of the protocol.
So application servers they can subscribe to a wide range of server traffic. For example, you can, when you are an application service, you can filter the events coming from a range of rooms and somehow react to those events. For example, you can take events, you can filter events that pertain to rooms that are supposed to be bridged to an IRC network or to a Telegram network. And then you can do something with those events, specifically broadcast those events to another network, to Telegram. They can lazy create virtual rooms because you have to be able to create a representation in matrix of something that happens in another network, in Telegram or in IRC or in Slack. You have to be able to produce the virtual presence in the matrix network for that other entity across the board. And they can receive the traffic by pushing, which basically means that instead of requesting events, they can be just pushed the events into themselves and asked to do something with them. For example, respond with information about the GitHub status. So I will quickly go through this because
a question about that diagram. Either I'm misunderstanding or that thing labeled bridge is actually a client of Matrix servers, right?
To be more specific, this is the application service,
right?
Which
so
is an extension of the client.
Right. So it doesn't handle the graph itself. It talks to that server it's attached to. And
that's right. That's right. It doesn't handle the graph. It receives.
So that diagram might be better if that bridge circle were a small size circle rather than a large. It's a very similar color to the graph and more than the same size.
Yes and no, because you still it's not a usual client.
It's
a client with very extended privileges. It has much more information than a typical client.
But it has much less privilege than the server.
In a way, but you can subvert a server if you have the application service privileges. You basically can, for example, you cannot do a state reset. You cannot mess with the state, but you can, for example, well, even put the server down, in fact, because things you can. I'm just trying to figure what the single worst thing that an application service can.
Well, I would guess for example.
Okay, you can just stall the communication in a particular room completely because you are you're receiving events, and you don't allow the server to send to broadcast them back, for example.
Right, but wouldn't that stall just that server and all the other servers in the Federation would be fine?
Yes, yes,
Okay.
yes.
And
This
the
is
bridge
still
cannot
resilient
connect to-
across the abuse on a particular server.
Okay, and that bridge cannot connect to any arbitrary server in the Federation.
No, the bridge
It
is
connects-
attached to a specific server
Right,
always.
okay. So basically, the bridge can compromise its server that it's connected to,
Right,
but cannot compromise
the
the
network.
network beyond that.
Correct.
Right.
Yes.
But within this Federation, other servers can basically make arbitrary connections to other federated servers.
We are working on.
Well, you're working towards that at any rate.
Yes, on
Okay,
this,
yeah.
on some kind of capabilities / permissions-based system
Yeah.
across the Federation. We came to the point when we have to tackle this. Now, this is what we started with. And basically, this is the current state that we are in. You can use SMS, email, Slack, Signal, Hangouts, AIM, to an extent Skype, ICQ, but who needs ICQ these days? Telegram, Twitter direct messages. You can do wall messages in Linux. So basically, all of that is already, in this way or another, is covered by this or that matrix bridge. So we've done already pretty much good job at unifying communications in a single place.
Do you have a way of dealing with end-to-end encrypted communications and keeping them end-to-end?
Across networks, no.
Okay.
Because,
Planning to do
well,
that?
you know, if something is encrypted over there, we actually have to, for example, in Signal, you have to somehow figure how to establish an end-to-end encryption across networks,
Right, so going
which
back to your
means
previous
harmonizing protocols.
Right. So, but going back to your previous diagram, if you did have any end-to-end connectivity, you would terminate at that thing called bridge, right?
Basically,
moment?
yes, unless the bridge is able to alleviate the differences between the protocols and pipe the encrypted communication through it without decrypting.
Well, then the client would have to know how to decrypt it.
Right,
It is
which means
reasonable
that
to say,
that the bridge has to somehow feed the keys to another network, and
No,
that exactly
that would
means
so
harmonizing protocols.
if you look at client on the upper part, might help if you go back to the diagram there.
Yeah, sure.
Okay. So if I wanted, say, take that very top green bubble, I wanted to go end to end there to the third-party client server, right? Which the bridge, if I'm doing end to end, can have no effect on. All it can do is forward the encrypted messages, right? But it should be possible to have my green client know enough about the Telegram protocol and change the way, or have enough support within the matrix protocol that I could actually do an end-to-end with a Telegram client at the far end, right?
Well, you still have
Effectively tunneling it, yeah.
As long as you, as the client in the matrix network, it has enough knowledge about how to decrypt and encrypt
Mhm.
messages so that they could be sent to the Telegram network, the client will be fine. But
Right.
again, this exactly means that the bridge
So
has
For
to
example, you need
do
be able to tell it
a
whether
tough
it's
job.
redfish, bluefish, onefish, or twofish.
Right, but does the matrix protocol support me putting in a packet saying, I expect this to be forwarded to a Telegram client?
Mhm.
It does.
Well, at the moment there is nothing like that. In
Okay.
theory, I think we can handle
Okay.
it. But again, I just don't believe that this can be done without both networks being aware of each other to a bigger extent than just making a bridge.
The bridge is always
things.
going to be, it's going to have to be trusted to some extent because it's going to be able to do things like arbitrarily drop messages or that kind of thing, unless you,
Right, but that's the level of trust you extend to the entire network between anything in the network can drop messages.
yeah,
So if the bridge acts as a proxy tunneling, effectively, you have a tunnel from your matrix client to a bridge that will serve as a proxy.
Yes.
to the Telegram network, then it could connect directly to Telegram, pretending to be you, but in fact unable to decrypt anything because all it does is forward Telegram's packets back
How's
to
the
you.
client know how to create a Telegram message that can be tunneled?
You have to have a client that knows how to do that.
Right, yeah. So you may as well have a Telegram client.
So
So, okay, we can.
Unless
So
Telegram
there
is
are-
blocked in
so-
your
so there are-
country.
No, well, yeah, okay.
So there are
So
basically
is an
two options.
application.
There are basically two options. Either the client knows from the onset that how to create the event that could be piped by a specific bridge to the Telegram network, like it's a specific way of
Mhm.
crafting an event.
Right.
You simply make a special envelope for that.
Yeah.
Or if we don't want to the client to know about that, to care about that, then that basically means that the bridge is supposed to be able to take a
Yes,
generic
I understand
message.
all of this. Actually, my question was, do you have specifically support for doing something like tunneling from a client?
Not right now.
Oh, not right now,
Not-
but
not
it could
right
be
now.
added.
Not in like for encrypted messages that doesn't work. For unencrypted messages, yes, this works already.
Well, for unencrypted messages, I imagine you're not actually tunneling. You're not
Well,
representing
it's-
each individual
it's
client
tunneling.
separately.
No, it's
It's a
tunneling
gateway.
because actually you get the event from the matrix server,
Right.
convert it to the Telegram message, and then send it to the Telegram server.
Right.
Right,
So it's tunneling.
this is the same as bridging between an IP network and.
Yes,
more
yes, yes. Essentially the same. Yes, you just convert two things between each other. That's correct. There is no major.
We live in a good country, it's Russia. We just have one country. If they do it in the US, they can do it.
Well, but that's assuming they can.
They did.
Where's my cursor?
Well, how do they prevent you from doing the DNS lookups you could use, for example, to transfer nodes from the graph?
But they would happily take that down too.
All of DNS, just period, no more DNS.
In Russia,
Okay. I mean, if you've got people doing that, yeah, you're stuck.
yeah, you're stuck.
But Russia's
They've
probably
got a really huge botnet and have it all.
Well, there's a particular case that I wanted to mention is that we actually have an app service that uses libpurple, which essentially means that you can plug whatever libpurple supports and try to interact with another network through libpurple. This is one of the cases when the app service actually really works as a genuine client to both networks.
Mhm.
Of course, the amount of functionality available like that is very limited. You can just send messages and maybe do some joining, leaving stuff with a particular network, but to a very limited extent. For example, you cannot establish calls. You cannot make a Skype call from Matrix in that fashion. The protocols are too much different. Well, that's one other way when an application service is useful. You don't interact with the network, you rather interact with the thing, with the device. So a particular app service receives events of a specific kind, and using these events, it manages a particular, for example, drone. A free switch. This is something that was actually used in production. Because in case of free switch, the compatibility between protocols is pretty much sufficient to establish call from matrix to a C. So that's basically the list that we currently have. Out of things that I haven't yet mentioned, we can interact with asterisk, which is actually similar to the free switch case. iMessages are already covered. Facebook Messenger is, well, yes, it's supported by, basically it's subject to Facebook benevolence. As long as they change the protocol, we have to do things from the very beginning. It's a similar case, I guess, with any other network that uses a proprietary protocol. So as long as the proprietary protocol gets too much different, or if, for example, a network is completely actively preventing people from interacting it in a grassroots way. For example, WhatsApp has been very specific and very efficient in preventing us from interacting with them, because they simply banned the clients, the WhatsApp clients that were not of its own. So we, like, at some point in time, they were just banned the WhatsApp client that was used to interact with metrics. Then I guess we've done just a single other attempt, and folks that were doing an open source client for WhatsApp went exactly the same way. Only in their case, that way took like 2 years, and in our case, it was just a few months. And that was pretty much it. WhatsApp doesn't want us in the community. Well, we can't help it.
Hello.
Yeah.
The other ones are all nice. I mean, for example, Slack, I think they also did shut down official gateways to IRC, so I would also
They still have
wonder-
webhooks, and we use that. They still have webhooks. Until now, they were not too hostile to that kind of interaction. So that wasn't at least as bad as the WhatsApp case.
Well, with Slack, it's done on a organization by organization basis, right?
Yes, it is.
So I would think Slack, if I say I want a Slack bot for my organization that does this bridging, they're
then
not
you
going
are
to tell me.
paying money, of course. Then you are paying money as company to
Yeah.
Slack.
Yeah.
Of course.
And so,
I think WhatsApp is
Yeah, I guess Slack wouldn't mind if you actually buy the paid account at them and establish a Slack bridge to Matrix and provide a service, like provide that Slack bridge as a service to your clients. That would be perfectly fine. At the same time, you can, for example, in a bigger organization, I can imagine a case when you have a transition from Slack to Matrix, and in order to do that transition, you basically have both the Slack organization and the Matrix server. Then you have the Slack bridge that simply makes the space of messages between Slack and Matrix continuous. And then eventually you just switch off the Slack organization entirely. This, as far as I can tell, this is the way that a few communities already took, because Matrix.org at the moment, and actually rather the company behind it, NewVector, has actually been invested by Status.im. This is the company that does the Ethereum-based, they call it operating system, but actually this is kind of a set of Ethereum-based application system, I'd say, not operating, rather application system. And they fed money into Matrix, but their collaboration started with the moment when Status.im discovered that Slack is not protecting the usernames from being aliased. So basically, another person can come in, have the same name as the founder of the room, as an administrator of the room, and ask Ethereum to be sent to him. And people would think that this is an admin asking them to do that, simply because the name is the same, the handle is the same, you cannot distinguish it in an easy way. And Slack has been not very nimble in responding to that threat. So at some point, Status.im just said that they cannot bear with that. They are dealing with serious things that are concerned with money. So they went away from Slack to Matrix.org, but their Slack channels are still there. At least they used to be there. Then I guess not by now. So yeah, that's one of cases how the transition from another network to matrix can occur, or how you can establish the interoperability within an organization between the two networks. VR, well, this is more like a fantasy at the moment. We do have some demos for that, but the idea is that at the moment you have completely siloed VR world. You cannot do anything between two VR providers. There is no interoperable communication there. So probably Matrix could be used in that way. And a nice picture. What we have recently gained? We have recently gained Jitsi video conferencing to the set of things that Matrix can interact with. So basically, multi-party calls that are initiated from Matrix, at the moment they are actually implemented using Jitsi. For example, you can establish a call inside a room of 10 or 15 participants. And this will be actually implemented in terms of Jitsi conference. Widgets are a very interesting extension to the protocol, which is currently being spec'd. Basically, we are putting this into the specification. The idea is that we are introducing a micro applications within rooms that can be interacted with using the Matrix protocol. Think of it, for example, if you have an Etherpad that you would like to collaborate with people chatting at the same time. So you have a room split into like the screen. You have it split into two parts. You have an Etherpad on top and the chat window underneath, or a Google Docs, which is actually already in use within the Matrix community. So you can edit and talk at the same time. Or you can, remembering the case of Twitch mentioned today already, you can look at the video broadcast through Twitch and chat in Matrix at the same time. Another thing that we have been happy to find out is that Librem 5 phone that is getting done by the Purism has chosen Matrix as their primary communication protocol. And I guess since they've chosen GNOME to be their primary environment, apparently the client for Matrix called Fractal will be used to interact from Librem 5.7. And the last thing that we have currently have is the groups communities, which is a way to combine rooms to not exactly combine, but have some kind of an aggregation layer on top of rooms, so that you could find out which rooms are referring to which topic. So it's a kind of a better way to discover rooms rather than just a room directory on a particular server. Some numbers, they are actually outdated already. Within the network, we have hundreds of thousands, and I think by now there are already millions of unbridged messages per day. We have thousands of federated servers. Mostly of them are using Synapse as the actual program. 60 companies are building on Matrix, including such huge people as Ericsson. This is the obligatory graphs, how we're growing. As you can see, on all accounts, the growth is exponential. So what's next? We have to stabilize the server-to-server APIs still. This is something that we are actually working on at the moment. The problem is that when it comes to server-to-server configuration, you have to deal with the fact that you are on the same level with your peers. When you, in case of server-to-client, you can somehow say that, okay, we have that protocol and clients have to obey by that. we have the permission system. We still don't expose the DAGs, so the server is kind of protected from abuse by the clients. In case of server-server interaction, we don't have that luxury. So we have to figure how to establish the good ways of communicating between servers, even in the situation when malicious actors are getting introduced on the server level. End-to-end encryption is getting finalized and most likely will be out as officially out by the end of the year. More and more people are already using it in the beta. Of course, we always welcome more hosted bridges, bots, services, and etc. We still don't have message threading, and this is something that people are actively requesting. Everybody likes threading in Slack, even as suboptimal as Slack implemented messages threading. Even that is better than having no threads at all. Message tagging like likes, for example, or votes is still in the works. Files have to be somehow tagged and also managed, because right now we don't have an option to delete files from a media server, from the content server. So it's ever growing, even if some files are no more referred to from the network. Decentralized identity is something that is also very interesting to work on, but there are very many open questions which are still unanswered, like on industry-wide, so we don't have any particular timeline for that. And of course, fixing spam, something like an eternal problem that we have to do in this way or another. We do have some safeguards already on the server level, so basically you can prevent particular kinds of events from even landing on the server side. But of course, that doesn't work with end-to-end encryption well. If the message is encrypted, then only another client can find out that that encrypted message actually sells Viagra to it. So this is something that we still have to tackle. But so far, I have to say that the spam problem is surprisingly low in Matrix. With that level of safeguards that we already have, we managed pretty well. So in a nutshell, that's pretty much all that I wanted to say. I can now go through a few pages to show what we have in stock already. So this is how BrightIM looks like. You can try the application even without making an account. There are several rooms here already mentioned just on the home page directly. The biggest room we've had originally was Matrix headquarters, but we had to recreate it recently because of an abuse with the state resets. There are rooms dedicated to particular clients, like for example, Riot, to bridges, to WebRTC, to end-to-end crypto. On each server, there is a room directory that you can browse through. And I'm currently connected to the Matrix org. There are more servers. And in case of specifically of Matrix org, we have IRC and Gitter bridges already plugged in and integrated into BrightIM. So you have the entire list from Freenode already available right here on the servers. You can use whatever room on Freenode, whatever channel in Freenode you feel usable. This comes with a caveat, not actually any channel. You have to explicitly establish the connection between a particular channel and a particular room in Matrix. You can connect to an arbitrary channel too, but we recently had an obscure behavior from some channel admins that are actually banning Matrix users from participating through the bridge. Well, I don't know why they are so concerned, but that's the way things are. So, we'll probably get to somewhere.
You said there's a company behind this. What's the model?
That's right. The company is called New Vector. Originally, these are guys from. Originally, Matrix grew up from Amdocs. In fact, Amdocs has financed it back in the beginning, like early on. Then, at some point in time, it became clear that the priorities and the goals of Matrix founders are not quite aligned with what Amdocs wants. I guess the turning point was when Amdocs found out that Ericsson is going to build something on Matrix, and they got increasingly disappointed with the fact that they are feeding money to Matrix, but Ericsson is not. So they are currently, basically, at some point in time, Matrix got spun out of Amdocs. Since last year, they are existing on their own, and they are providing services like, for example, running the commercial installations, commercially supported installations over home servers. They are doing some consulting for Matrix. So the model is like that. So the original code, both for home server, for Riot, it's open source, it's licensed under Apache license. And people behind it are basically leading off consulting and custom installations work. They have got a very huge breakthrough recently when French government announced that the ministries in France are going to use Riot as the primary communication tool. So that I guess New Vector has received some money from the French government to support the transition process. Then basically there is nothing preventing a company from making the commercial closed source server and rolling this server, or from using the open source server and taking money for simply for running this server. Because at the moment, for example, Matrix.org is actually overloaded. So I'm not showing too much of it because at the moment it is slow. It's almost constantly DDoSed. Unfortunately, the guys are simply struggling with the growth, which immediately makes the point for setting up a separate server and selling the unrestricted, basically proper, fast access to the server to other people, both individuals and organizations. So that's basically the model. Oh, okay. Oh, why? It's pretty screwed. And even that. Well, okay. Just try it. Yeah. So, disclosure. This is my own client. Not Riot, but the room dedicated to Quaternion and Matrix clients. This is actually the room I'm running, and the client is of my own. the client itself, by the way, looks like that. So this is the usual IRC flavored way of presenting a timeline. And you have the room list to the left and the user list on the right. And I can make the timeline layout a bit more Skype-like. So this one is on Qt. There is a similar client on GTK, but it's more like it has more GNOME looks. Another client on Qt that has been made for more again Telegram looks is called Heko, and it's also full-fledged client providing all the messaging, files, uploading, downloading, basically all the stuff that you would expect from a messaging network. Okay, I think I already took too much time of yours. So in case of any specific questions, let me answer them.
Yeah, I got a question. You say metadata is not encrypted at all, so do you plan on any onion routing or something?
There is a trade-off. You either connect bridges, you either connect extended application services that can look into the content of events and react accordingly, or you have the metadata encryption. So as long as you have metadata encrypted, you have to provide some routing information to servers, because it's not always that you can even understand where this message is supposed to go further. You at least have to figure which room this message belongs to.
So it's not possible to send a message directly to the server to encrypt the message, and in this message is another message to be sent to another server. So like
the approach, well, the thing is that messages are, of course, encrypted client side. You can run a server next to your client. And in that case, you can actually have your server do whatever you want with the message. You still have to do something about routing, but since the communications are already encrypted by TLS, you can somehow alleviate at least the fact that you are sending something to that particular server. Like that something can be encrypted. You still have to have the, like you are still leaking the information that you are connecting to that other server, but that's already better than what we have right now. There is an idea, and let me, I think I have a slide for that. So there is an idea to combine matrix with Tor the idea is that you exactly roll out your own server, then the server connects to Tor network, and in this way you can conceal the information that you are even interacting with some specific other server to send whatever is already encrypted. So in this way you can even hide the information that you are interacting with somewhere. But this involves Tor. That's basically the best approach that we can take. If you are connecting to some other server, you are inherently leaking the information about the room, at least about the room that you are sending messages to. And of course, the very fact that you are connected and that you have joined a particular room can be too revealing for some people. So that's basically the way out. Host your own server, then you are kind of protected.
So that would protect from people in between knowing where you're connecting to. It doesn't protect from service, I guess.
No,
Like
if there is a server looking into your communications inside the network, like an agent,
yeah.
and if
Yes,
FBI runs their own home
server.
then FBI will know that a particular person, like a particular user ID, is writing in a particular room. So that information is apparently linked to any server that is inside the network. The counteraction against that is to establish your own matrix network separate from the community. So, in fact, one of the possible options, and that's, I guess, that's one of the things that I plan to roll out in my own company, is to just set up a server inside your own organization. You can roll out such servers in any office of your organization across the world, the organization, if it's an international corporation, for example, and not interact with the outside world at the same time. You can host it entirely inside your VPN, have those servers federate with each other, and have your own communication network, your corporate communication network in that way. So you are not leaking anything, any information about your own internal stuff to the outside world in this case. And there is even more flexibility if you establish a particular set of rooms on a particular server that the server is authorized to federate to the outside world. This is possible. You can configure a server so that it only federates specific list of rooms. Then you can have, again, inside an organization, you can have organization-specific, like internal intra-corporate rooms, and you can have specific public rooms, which means public as open to the rest of the world. So this is also the way of interaction for corporations like Dell or NEC, for example, who have their proprietary stuff, but at the same time they have public stuff, open source in particular, that they want to communicate with the outside world as well. Okay?
So you say the encryption is a late beta. Is it very different from like the signal encryption protocol, or because I barely found any third-party clients which support the encryption, and I think it's currently not default and turn it on.
Yeah, the thing is, Matrix is oriented to multi-party rooms in the first place. Signal encrypts one-on-one communications in the first place. The protocol underneath is very much similar. It's the same double redshift used in Signal and in Matrix. However, Matrix people implemented an additional layer on top of double redshift. Basically, they've made their own implementation of the double redshift protocol, first off. The library is called Olm. It's hosted outside of the United States because of cryptography restrictions. Next to Olm, there is another library called MegOlm, which extends double redshift to multi-party rooms. So MegOlm enables encrypted communications in rooms across hundreds of people, for example. The issue with MegOlm is that since you have to encrypt information in such a way that all others can decrypt it, you have to establish basically a full mesh exchange of keys across all the participants in the network. And performance becomes a really hard bottleneck. Given that the primary client is web-based and things are actually running in JavaScript, it's hard. So that's basically the thing. And we already have some clients non-web-based. In particular, that client in Heko that I mentioned, it's already implemented end-to-end encryption using MegOlm, So you can use NACO to interact with Riot in an encrypted fashion. And as far as I've seen, it works actually considerably faster than Riot does. Still, the entire thing is a bit raw around the edges. You still have to, like, for example, there are problems with proper preserving of keys across your own devices. When you are connected to the network from several devices under the same account, you would naturally want those devices to be pre-authorized across them, inside them, which means that those devices have to somehow automatically exchange keys between themselves without probably you even know. This is something that is currently worked on. The next problem is when you log off, you have to preserve keys somewhere unless you are okay to lose all the encrypted communication that occurred before that. So that's again something that is not very convenient at the moment. It's there, you can export the keys and then import them, but the entire UX is kind of meh. So that's basically things that we are waiting for.
Those are both problems that existing end-to-end encryption systems are not trying to solve.
Sorry?
Those two problems you just described are problems that systems like Signal and other end-to-end encryption systems are specifically not trying to solve.
Signal is not addressing the multi-party encrypted communication.
And it's also not addressing being able to go back and look at old communications. If you lose your keys, it just says, okay, those communications are gone.
You're
and that's
correct.
actually desired behavior.
You're correct, yes, and we want to do something better than that. Yes.
Well, what you're doing is not better, it's different.
Well,
depending on what the end user needs.
after all, when you have the ability to nuke your keys and you have your keys nuked, no way, like you just don't have the way to not nuke your keys when you log out. And probably the first option is still provides you with more flexibility.
You do get more flexibility, but what you're talking about with copying
Rope to hang
keys
yourself.
can limit your ability. In fact, it's not necessarily more flexible. It can limit your ability to say, I want to make sure that other clients can't see this.
You can make sure that other clients can't see this if you just throw out the keys. Okay, we cannot.
Right, but if how do you
okay,
make sure your
point.
keys never get to other clients?
I got your point. Let's put it that way. Once something is out, it's out. So if you've sent some message, even encrypted, and once you've set the public keys for that message, you cannot consider them not existing anymore. They are already in the network.
Sure, but public keys are no problem for that. The question is, if you want to have a private communication, truly as private as possible, you definitely don't want your particular client here doing key exchange with the other client that's logged in on your other PC.
Then just don't do that communication with other clients than ones you trust.
Right.
The thing is, if you have the room and you have exchanged the keys within this room, those keys don't go anywhere beyond that room. And even servers...
Well, your private keys don't go into the room at all, right?
No, private keys are stored on
so
the
that's what
client
I'm
side.
talking about is private key management.
They are entirely stored on the client side. If you can try to exchange your private keys across your own devices, and the way to do it in a secure manner is currently discussed.
Right. So Signal specifically does not let you do that.
Precisely, yes.
Right.
Yes, that's true.
And it's not considered a problem with Signal.
Yeah, they do not think it's a problem.
In fact, it is a solution for certain kinds of communications.
Well, yeah, maybe.
Yeah.
Maybe. I'm still not sure if metrics cannot provide the same level of the solution at the same level of security.
Yeah, I think you could, yeah.
So that's a matter of configuration in the end. After all, the rooms can be simply configured to different modes. and you can configure a room, for example, which just does
Yeah,
not
this isn't
allow
actually anything to do with the
anything to
room, is it,
exchange.
given that it's end to end? Because all the clients are doing is putting encrypted messages, encrypted and authenticated messages onto the blockchain or the graph. And so the room doesn't care what would be configured about the room to change how the clients use that.
Well, we could establish in a way that the room configuration defines how other clients and servers are working with it.
Yeah, it sounds like a huge security hole to me. As soon as you say, rather than determining my own security as a client, I'm going to take it from
it assumes that clients are behaving. That's right.
No, it assumes that servers are behaving. If my client, if I'm encrypting something, I should not say I'm going to change how I encrypt it based on this room setting. I should say I want to have this.
But servers have no way to look into the contents anyway.
Correct.
So
but if you say room settings, I assume that's a setting that clients should follow based on what has been changed in the graph, right?
No, my point
Is the room not the graph?
The room is the graph.
Right, okay.
And you have the settings in the room, but those settings can be encrypted themselves. So you can put a setting and then have the clients obey that setting, but this setting is analyzed only on the client side.
So
Servers
keep in
don't
mind,
know about it.
that means that someone, if they manage to take over, for example, one trusted client can change the settings of other clients. Say from, I start a new so-called private conversation that I want no other client to have access to, not even my own other clients. But if my client here might follow some setting I wasn't aware of, changed on another one of my clients that compromised to say, these keys that you thought you were not giving out to your other clients, you now are.
Let me think how we can solve it. No, I think at the current state of the protocol and at the current state of mind, given that not the entire protocol is still
well, it's simple to solve. This client must say, if I specify no other clients, including any of my own clients, may have access to this conversation, it will never give the new private key it generates.
Look, the client actually, I have an answer. The client actually chooses whom, including the specific devices, to share the keys with.
Right, yeah.
So that basically means that the client can specifically pick, I want only this device to be aware of this conversation.
Right.
And problem solved. You don't have
But you have to have the client pick that, not look at settings on the graph that have been set by other clients.
The client picks that. It's not about settings.
Right, so it's not part of the room settings then.
No, it's just a single two-device message that contains the public key, and that's
and presumably you're generating a new key pair for that conversation then? Right.
Yes. So actually the keys are generated for each conversation.
And then you actually
the redshift actually is switched every now and then.
So actually you are getting perfect forward secrecy there too. Then,
BFS is there.
Yeah.
Yes. Okay. Other questions? Probably we finally close it.
I asked you later.
Okay. Okay, thank you very much.